Hey, hi everyone. My name is Nikhitha. I'm a recent graduate of the Aerospace Engineering program here at Carleton. I just wanted to talk to you a little bit about the different types of engineering we have here to offer. So why choose Carleton for engineering? We have world-class labs and facilities. We offer experiential learning, which means there's a hands-on element to your education. We have generous scholarships, award-winning professors, numerous academic support services here at Carleton, as well as that self-contained campus and community feel. And of course, being in Ottawa, we have the capital advantage. An engineering degree is a pre-professional degree. What this means is that you need to graduate from a 4-year undergraduate accredited university program, get 4 years of work experience under a licensed professional engineer, do a professional practice examination, and get good character references. After you've met all of these requirements, you'll be able to call yourself an engineer here in Canada. If you do study in Ontario, you'll need to be licensed by the Professional Engineers of Ontario, otherwise known as the PEO. At Carleton, we actually have the second largest engineering faculty in Ontario, which means that we offer a lot of different programs. In this slide, we have 13 different engineering programs that we offer in our department, and I'm just going to be going through each department and talking a bit about the programs. So our programs are housed in 4 different departments. I'm going to be talking a little bit about the Department of Electronics, which houses our electrical engineering program. This mainly is a traditional electrical program. We're focusing on how electricity interacts with different systems, how to deliver power to homes, small circuit design, smartphones, anything that would have an electrical component is what our students are looking at. You can specialize your knowledge in 3rd and 4th year by taking electives in things like fiber optics, circuit design, microprocessors, and sensors, and kind of tailor your degree a little bit into what kind of field you want to go into after graduation. Possible jobs in this area are typically in design for products like in the electronics industry, computer industry, power industry, or telecommunications. So there is a lot of options with this degree. We then have our engineering physics program, which is really focused on nanoscale technology. So it is joint with the Department of Physics here on campus. Students take about 60% of their courses in engineering and the other 40% with physics. The program is focused on research and kind of applied sciences and nanotechnology, quantum computing, and semiconductor design. As you can see in the picture on your right, that is our microfabrication facility that students can actually design and manufacture their own silicon wafers as well. So that's a neat lab for students to use on campus. We then have one of our streams of our Sustainable and Renewable Energy Engineering program called Smart Technologies for Power Distribution, Power Generation and Distribution. This is housed in our Department of Electronics, and we are the only university in Ontario that offers a sustainable renewable program with an electrical feel. So what this means is students are really focused on how you get those renewable energy sources. So your solar, your wind, your hydro, your geothermal, and how you generate that electricity efficiently and how you actually deliver it to customers. So in the picture, you can see kind of a network of residential housing, and they're delivering, the purpose goal of the project was to see how to actually deliver power kind of efficiently to those houses at different times of the day. So maybe where there's more users using power at night when people are home from work, and there's less people using it during the day. So they really try to focus on efficient energy and how to distribute that to your local communities. We then have our second department, which is our Department of Mechanical and Aerospace Engineering, which houses 4 different programs. One of our coolest programs here at Carleton, very popular, is our Aerospace Engineering program. This offers 4 different specialties. It is direct, all of our engineering programs are direct entry, so you do have to apply for the program that you want. At the end of your first year, you can choose to specialize in 4 different areas. So we have our aerodynamics and propulsion stream, our structures and vehicle design stream, our aerospace electronics stream, and our space systems stream. So we really focus on things both in our atmosphere and outside of our atmosphere. So we're not just looking at aircraft, we're looking at UAVs, drones, rover design, satellite design, and various things, both kind of your traditional aeronautical as well as a space engineering degree. We then have our biomedical and mechanical engineering program. So this really focuses on the human body as a mechanical system. So you take various courses on how to interface with the body. So things like prosthetics, as well as implant design. You're testing strength of bones, different materials that you'd be implanting into the body, and really how those are going to move and work with the body to make it as close to real life as possible. In the pictures that you will see, we have our crash test dummy project. So students actually 3D print a dummy. It has sensors in the head and the chest, and they actually do a bike and vehicle collision with it, and they get sensor data as well as kind of a case analysis. So they'll like a crime scene analysis of the area to get more data to help with bike and vehicle collision. So they're looking at that aspect of it. The other picture you'll see is called our ITAD. So that's our Intelligent Presence Assistive Device. So it's meant to be able to kind of navigate itself throughout the hospital. If there is a doctor that's away or something, they can video call in, and the device should be able to take things like temperature reading, blood pressure, basic readings for the doctor to be able to get a basic sense of how the patient is feeling. So on this slide, you'll see our mechanical engineering program. This is a very broad engineering discipline. Students are working kind of in any industry that has moving parts. So anything from aircraft to roller coasters to the biomedical industry, they're really involved on a much broader scale. So the learning you're getting is a little bit more, is a lot broader, and you're not going as in-depth as some of our more kind of specialized program. But mechanical engineers are found in most industries in the engineering field. In the picture, you can see our Ravens Racer. So this is actually part of one of our 4th year capstone projects. Students actually build, test, design a car from scratch every year, and they race it in various competitions in North America. The great thing about this project is not only do students work on it in their 4th year, but you can join the project anywhere from your 1st year through to your 4th year and be part of the team. So you would help with design analysis. Students also get to drive the car at these competitions, so there's various roles that you can play. It's a very nice way for students to kind of get experience in manufacturing, CAD, things like that, areas maybe they're not as comfortable in during their class. It allows them to get that extra experience when they're doing our 4th year projects. All of our programs do have 4th year projects. So as you saw in the previous slide, there was the crash test dummy and the ITAD machine. Those are all projects students can choose to work on as they progress. We then have our second side of sustainable and renewable energy engineering. So that's our efficient energy generation and conversion. So these students are really focusing on kind of the mechanical side of producing energy. So anything from your wind turbine design to your solar panels. So how are you actually producing in manufacturing the equipment that's going to get you your mechanical, your wind energy, and use that to produce your electrical. So this picture here shows our sustainable house. So it's a net zero residential house project. Professors and students are looking at how to make residential housing net zero. So they do various experiments on campus at that house. They'll implement different technology and look at how it affects the house and the way it produces and uses energy, and how it differs kind of in the winter and the summer and the different seasons that we have here in Canada. We then have our third department, our Department of Civil and Environmental Engineering. We have our Architectural Conservation and Sustainability Engineering program. So they're really focused on sustainable development and heritage conservation. So what that means is they're looking at really old buildings, so like our Parliament buildings here in Ottawa, which are a couple of 100 years old, and they are looking at how to make sure that those stay around for a long time. How can they make them more sustainable? So, you know, putting better lighting, looking at the different infrastructure, the materials, how to make sure that it stays around for a long time, looks the same, but is more energy efficient. So they'll look at things like green building design, retrofitting existing buildings, life cycle costs, impact of, you know, selected materials, energy needs and consumption. So lots of different things. The picture on your left is our tiny home project. So that's an interdisciplinary project with multiple engineering streams. And students are looking at small homes with net zero kind of energy. So any energy it uses, it produces by itself as well. So it's not, there's no waste of energy. So that's another aspect of the Architectural Conservation Sustainability program. We then have our civil engineering program. Again, this is more broad type engineering. They look at things like highway and transportation. You're looking at geotechnical design and various other aspects. So here at Carleton, we really focus on structural in the civil field, highway and transportation, as well as geotechnical engineering. So students can further specialize again in their third and fourth year with their electives. And students work in lots of different industries. So anything from building your road infrastructure to bridges to the housing industry, different areas that students can be involved. We then have our environmental engineering program. So this is very much chemistry focused. Students are looking at clean water, clean air, clean soil, and remediation, prevention of these different things. So how do you prevent your water from actually getting polluted? How do you make sure your air quality is good? How do you make sure nothing's happening to the soil or where you're building? And if something does happen, like if there's an oil spill, what kind of technology can you create or use to clean up that spill? How can you reduce waste? How can they improve, you know, have more efficient recycling systems, treatment systems, things like that. So they're really looking at it from an environmental standpoint. Students also will look at different sites. So if you are going to be putting a building up, you know, you need to do an environmental assessment impact test to make sure, you know, you're not contaminating the land. There aren't previously existing contaminants. So they really work in a multitude of industries, but their focus is again on that clean air, clean water, and clean soil. So as part of their fourth year final project, students actually get the chance to go to Tanzania for a capstone project called From Buckets to Rain Barrels. So this is a multi-year project that's been going on for a few years here at Carleton, and we do take students from other faculty as well. They develop products here over a 4-month period, and then they get the opportunity to go on site and test out and get feedback from the members of the community. So things they're looking at small scale solar still design, drip irrigation, water saving mechanisms, improvements to brick making and ceramics, filters for water treatment, and various things like that. So they're really looking to go in a more community-based focus. Again, you know, that focus is looking at the different systems they have in place and how they can improve it as they go on. Our final department is our Department of Systems and Computer Engineering. This houses 4 different programs. So we have our other biomedical program, which is more of an electrical systems field. So they're really looking at the body as part of an electrical circuit. So when you put sensors on the body, you don't want to electrocute anybody. So when you're doing that kind of design, when you're doing anything with image processing, so your x-rays, your CAT scan machines, they look at EKGs and ECG machines as well. So they're really looking at more electrical systems focus versus mechanical stream, which looks at prosthetics and various things like that. Usually students kind of go into the healthcare industry or medical facilities. They look at medical equipment and medical devices to design those and maintain them. And they look for developing like healthcare technologies, electronic implants, safer medical instrumentation and devices, and management of kind of diagnostic systems. So it really kind of gives you that other side of the biomedical industry. We then have our communications engineering program. This really focuses, if you see in the picture, on the Internet of Things. So anything from big data to smart grids to telecommunications, your smart infrastructure, automation, cyber security. So they're really focusing on, building and developing the infrastructure to make sure all of that can happen. Our next program is our Computer Systems Engineering program. At most schools that you might see, it might be called Computer Engineering. The reason ours is called Computer Systems is because it really is a combination of kind of hardware and software. Students take electrical engineering courses as well as software courses where they do programming, and they're really learning how both systems kind of interface. So when you do develop something like a drone or a robotic, not only are you speccing out what's going to go in it, but how do you program those electronics devices that are on to perform specific functions. So they're really looking at how a system works as a whole versus just the individual sides of it. We then have our software engineering program. So again, this is a very kind of traditional program like your mechanical, electrical, and your civil. They are looking at designing software. So they look at different programming languages throughout the 4 years. So they'll do things like Java, C, C++, Python as well. And they're looking at this, you're looking at the software development cycle. The key difference between this and a computer scientist, computer scientists typically focus on kind of algorithms and small scale kind of snippets of the code, whereas a software engineer kind of looks at it as the big picture. So how do all those algorithms, fit together to make the program work? What are the social and economic and ethical impacts of the software that you're creating? So things like autonomous vehicles, of course, those are heavily programmed. You're looking at the impacts of what you're designing to the real world, which is typically engineers, what engineers look at. Housed under our faculty, we also have our design schools. So you can get a Bachelor of Architectural Studies, Industrial Design, or Information Technology. Our Architectural Studies program does require a portfolio, so you do need to make sure if you are applying that you do have a portfolio ready for that. It is a 4-year program, and you apply directly into one of the 3 streams that they offer. So there's the design stream, which is very much focused on your studio work, drawing, design of a building. We then have our urbanism stream, which is more big picture design. So you won't just look at designing a house or a condo building or anything like that. You'll look at more on the scale of a full city or an area in the city. So where do your high rises go? Where do you put low rises? How does the traffic move through your area? What are the green spaces? So they look more at big picture type of design. We then have our conservation and sustainability stream as well. And their focus is, if you do have an old building, how do we add infrastructure to that. How are your new materials going to react with the old materials when you kind of interface that? So they do take a couple of the civil engineering courses as well to gain that structural knowledge and those material knowledges as well, but they are definitely looking at more sustainability kind of design. So the difference between that program and the Architectural Conservation Sustainability Engineering program is the one in architecture does focus on design and is more studio, more kind of materials analysis, that kind of area, whereas the engineering program is definitely more technical. So you are doing more kind of analysis in that. We then have our Bachelor of Industrial Design. So these are really responsible from kind of concept to design to actually manufacturing process of any product. They really work behind the scenes to kind of design features, appearances. They look at ergonomics, materials of products. So if you think of your cell phone, for example, they look at not only the packaging, but what goes in the packaging, how you actually open your box, how you unpack your phone. What things go in the box, so like your charger, your headphones, how those actually come out of the box. They look at the user interface as well. So if you look at sometimes an Apple Watch will have a heart as your kind of heartbeat sensor. They're really looking at UX design as well. So they're very much user focused. It is designing products for millions of people of vast demographics. So they're really looking at how you can design a product to fit many different, people in the world. So whether they're short or they're tall or they have, are from different demographic areas, they're really looking to design en masse. It is also a portfolio requirement program, so you do need to submit that when you come into that. The design students are really kind of integrated into a lot of the different areas. They look at both technical things with engineering as well as business focus. They look at psychology as well, because you need to understand how humans think to be able to design for them. Because they are producing en masse, they are looking at that business side of it as well. So typically a lot of these students will go on to get MBAs. But you can also pursue a master's in design here at Carleton with that. If it is a program that does interest you, but you do want to do maybe an engineering program or one of our other design programs, you can take a minor in design here at Carleton after you finish your first year. We then have our Bachelor of Information Technology program. So there's 4 different programs in this school. So we have our Information Resource Management. So they're really focused on big data, like archiving, research, various things like that. All of our Bachelor of Information Technology programs are joined with Algonquin College here in Ottawa. So students take about 60% of their courses in their 4 years here at Carleton and the other 40% at Algonquin. The nice thing about this is students actually graduate with both a degree in information technology as well as an advanced diploma from Algonquin, depending on the program that you are in. So typically a college degree and a university program would be 7 years if you did them separately. But the nice thing about this is it takes you only 4 years to complete. So again, the students are looking at managing digital resources, research data, social media, where does your information go when you put it on the cloud? How can you easily access that? How is it managed on the back end? And things like that. Students in the IRM program can also take minors throughout their degree. So you are able to take minors as you're going through this program as well, which is a neat little add-on. We then have our IMD program, so Interactive Multimedia and Design. So this really is a design type program with a technical aspect. So you're looking at how you're using your different software to do design work. So your Adobe Suite, Maya Studio, your CAD, various things like that. So they learn everything from graphic design to animation to producing a website, Photoshop, and various things like that. So they really are looking at using your kind of software and things like that to produce different design work. Students in this program also do a fourth-year capstone project. So at the end of the year, they'll present. Some students will make video games, they'll do computer animation or slow motion pictures, things like that. And they'll present that to industry and professors as well. Some students actually go on with their fourth-year project to actually produce games that you can find on like the Google Play Store, or your Apple iStore, and various other areas. It's a very cool program here as well. And again, students will be taking 40% of their classes at Algonquin. We then have our NET program, so Network Technology. So it focuses on the design, management, operation, and installation of complex information networks. So like the internet and your cell phone networks. The program is multidisciplinary in nature, so you take courses in computer and network technology, some courses in physics, math, business, as well as communications, social sciences, and various others. The nice thing about our NET program is that there are certifications built into it, so students can get their Cisco Certified Network Associate certification, so your CCNA, as well as you get the training to write your CCNP as well. Students can also do their Nokia and Juniper certification in this program, and a French minor as well is built into it. So students are able to get some French learning as they progress through this degree. Our last BIT program is our Optical Systems and Sensors. So this is really looking at how we can use light technology for various equipment. So things like autonomous vehicles, those use what are called LiDARs to actually detect the world around them. And there's various other industries that uses light technology. So when you're looking at fiber optic communication, things like that, that's all light technology. So students are really looking at, your foundations in physics and maths to really build their skill set in the optical systems and sensors program. It really is a multi-trillion-dollar industry, and students are working with the latest and greatest technology when it comes to kind of electrical and computer engineering. And there is quite a high demand for these students in today's industry. So it's a very interesting program if you are interested in kind of using physics and math and learning about how that integrates into the real world. We then have a Bachelor of Media Production and Design. So this is not with the Faculty of Engineering and Design, but students go to the School of Journalism and they will take a couple of courses with our IMD students. So they're really looking at different technologies that can help them better communicate stories and, send information as well. Through kind of online media and using tech to do that as well. So they will take a couple courses with IMD, but you would have to apply through the School of Journalism for that. So now that I've talked a little bit about our different programs, we do have a lot of labs and facilities as well here on Carleton's campus that students have access to throughout their 4 years. So we have everything from our motion capture studio for our interactive multimedia design students to various machine shops, maker spaces, and other labs. So if you look at the pictures, you can work in our extraterrestrial lab where students are looking at Mars rover technology. We have autonomous vehicle research here on campus as well, net zero housing research, we do satellite design, and we even have facilities where we have industry equipment like our Hydro Ottawa lab. So that's equipment donated to us by Hydro Ottawa, so students in the Sustainable Renewable program can actually do real-time simulations of how their power distribution is going to work and things like that. So we do have lots of labs for students to look at. In our design schools, again, students have access to our wood shops, sound recording studios, various maker spaces, 3D printers, and such. And students are really able to kind of hone in on those hands-on skills that you won't necessarily get from a purely theoretical background. Students are also in these labs from their first year. So in your first year, you don't spend all of your time in lectures and labs. In lectures, you do spend some of your time in labs getting that hands-on experience to really kind of show you how your theory is going to be applied when you go out into the real world. We then have co-op options for all of our engineering and design programs. Typically, these are placements in the public and the private sector because we are in Ottawa and have the government close. Students can go to a wide variety of cities for this. Typically, if you are in the P.Eng program, we do recommend you do your co-op in Canada, as 12 months of your 16-month co-op can count towards your P.Eng 4-year work experience. So co-op does add an additional year to your degree, but it can take away a year of your 4-year work requirement if you do want to get your P.Eng license. Co-op is also paid, so it can help finance your education, and you kind of gain some practical experience to see if you really like that area that you're working in. Co-op does have different costs, so you are paying an admin fee and a work term fee. So anytime you're searching for a job, doing a co-op course, you're paying that administration fee, and anytime you are out on the job, you are paying a work term fee. What this means is there's a supervisor who comes in and checks in on you. You always have a resource here at Carleton, you know, whether you're on campus or off campus, to access our co-op services. So typically students are looking at 4 work terms. Different programs will have 3 or 5 work term requirements to fulfill to get the co-op designation on your degree. So definitely look at the different programs. Carleton has access to over 5,000 different employees. On this slide, you'll actually see a couple of the companies that regularly hire from Carleton. So we have places like Google that will hire anywhere from our software to our BIT students to Shopify, Cisco as well, our optical systems and sensors, electrical, Curtiss-Wright, for your aerospace mechanical. So there's lots of different companies that students can work at just here in Ottawa. So what do you need to actually get into the program? So there are various requirements. These are the Ontario requirements, so it would be different if you're doing the A-level or IB program. In engineering, we really are looking for your advanced functions, so a math, chemistry, and physics. Our industrial design, interactive multimedia design, and our architecture studies program all have portfolios, so there are earlier deadlines for those submissions, and you do need to submit a portfolio. But you can definitely go online to see the various requirements for your high school program, whether that be AP, A-levels, IB, SAJAB, anything like that. So tuition costs, very important. Typically tuition for international students is around $36,000 for engineering. We typically are on the higher side because you do have access to a lot of software labs in our facilities. If you will be staying on campus, that's an additional $10,000 to $14,000, which includes your residence room, your meal plan as well. If you are living off campus, it is slightly lower for that, and of course that's just rent and utilities. There is some fees for books and supplies as well as personal expenses. So typically for a total year, if you are coming into our faculty, you're looking at the higher end, so around maybe $49,000 to $54,000. But your tuition typically is on that higher end of the tuition. All of our students do get automatic entrance scholarships, so starting at an 80% to an 85%, you are going to get $1,000 per year for 4 years. and any 5% increase is an additional $1,000. So you can get up to $4,000 per year towards your education. You do have to maintain an annual GPA of 10.0, which is about an A minus, so that's that 80% per year. If you don't maintain that average, you will lose your scholarship. However, if you do bring your average back the next year, you'll be able to get your scholarship back. So your scholarship's not truly ever lost. There's always ways to get that back. We also have prestige scholarships. So if you do have extracurriculars and grades above 90% in high school, you can apply for one of these scholarships. So it's one application for all of them, and they range from about $5,000 to full Canadian tuition. So it wouldn't be the full international, but you could get up to full Canadian tuition for those. Again, you would have to maintain that A minus GPA per year to keep your scholarship from year to year. So we do have dates and deadlines for your application. So for fall entry, so fall 2020, you do need to apply by April 1st. If you are entering in the winter semester, you do need to apply by November 15th, but none of our engineering programs are available for winter start dates. Again, if you are looking at our design programs, architectural studies, and industrial design and information technology have earlier deadlines and as well as portfolio deadlines. So you will need to submit your application for architecture by February 1st and submit your portfolio by March 1st. Industrial design and information technology has an application deadline of March 1st and portfolio deadlines of April 1st and March 1st as well. So now I've talked a little bit about expenses and dates and deadlines. How do you actually transition to post-secondary? So coming in as an international student, I had never seen snow, cold weather. You really are coming from a completely different culture. So it is great to make friends and get involved in the Ottawa area as well as the Carleton community. So I had some great friends. In the pictures you can see that I attended events kind of all over the Ottawa area. I went canoeing, kayaking for the first time on the Ottawa River. I went to see Parliament Hill. I attended sporting activities hosted by the university. And various things like that. So it is really great to kind of see where you're living, attend events. There's tons of events in Ottawa throughout the year, no matter the season. So it's always great to kind of get involved and enjoy the city that you are living in as well. While getting to know the city is great, it is also a transition from high school to university. There's typically not someone telling you when your dates and deadlines are, when you need to hand in assignments and various things like that. So we do have academic support services to help our students kind of make that academic transition. We have peer-assisted study sessions, or PASS. These are facilitated by somebody who has taken the course and has an A- grade or higher. And they actually attend class with you so you can ask questions, and they host workshops every week to go over the material you've learned in class. We also have our Elsie McGill Learning Center. So this is for first year engineering students. They can go up to the center. It's fully staffed by engineering scholars, and they'll help you with any of your first year courses. We also have linguistic scholars as well. So for any of your technical writing or your non-engineering courses, like electives that have writing components, they can help you with those as well. We also have our Paul Menton Center, so those are for students with visible and non-visible disabilities. So if you need extra time writing exams, someone to take notes for you, various things like that, they can help accommodate that. And one of the great things that I personally love about Carleton is we have a huge therapy dog program here. And there's about 13 dogs on campus that you can, visit and just have a little pet to kind of de-stress. At Carleton, we have tons and tons of clubs and societies. I'm just going to focus a little bit about the engineering. So you can join any of our clubs from your first year all the way through to your fourth. All students will be part of our Carleton Student Engineering Society that hosts events throughout the year. We have our C-Eng musical, so those are students actually put on a musical themed on a pre-existing musical, but they make it very Carleton engineering themed. So we do things like Grease, and they called it WD-40. We did things like Frozen, and that was called Absolute Zero. So there is kind of that engineering play on it. We also have stream-specific societies. So if you really want to be part of the Biomedical Society, the Carleton Mechanical and Aerospace Society, there are societies for all the different programs. We also have international student chapters here as well. So things like the Institute for Mechanical and Electrical Engineers, the Canadian Society for Civil Engineers. There's lots of ways you can get involved in the community. We also have various clubs and societies. So if you do want to be part of competitions or you want to kind of get more hands-on experience with an area that you're more interested in, you can definitely join one of those clubs. So we have things like our Carleton Planetary Robotics team, and they build a rover every year and go to competitions in North America. We have our Great Northern Concrete Toboggan Race. So they actually build a toboggan out of concrete and race that in different provinces across Canada versus different universities. We have our Trotsky Bridge building competition. So teams from Carleton will actually go and build bridges that have to do specific things like hold a certain amount of weight, be a certain length, be at a specific material. So there's really a way to get involved, meet people that have interest in areas that you have interests in, as well as getting more hands-on kind of experience. So like I mentioned in my very first slide, so we are a self-contained campus with community feel. So everything you need can be found here on our campus, from our academic buildings to our residence to our own walk-in clinic, dentist, and pharmacy, as well as stores where you can buy various things like food. If you don't want to be on campus all the time, you also are provided with a transit pass with your tuition, so you can take any of the buses or trains that go through campus to anywhere around the city. We are about 20 minutes away from the downtown core by bus, and 20 minutes away from the Ottawa International Airport. So there's lots of different ways that you can get to where you need to go from campus. If you do want to know what we are doing here at university, you can definitely follow us on any of our feeds, Instagram, Twitter, and Facebook, just to get a feel for that. So thank you for all of your time. If you do have any questions about admissions, you can definitely email international@carleton.ca or visit their website and join them for weekly chats every Tuesday and Thursday.